right, question 8 on the math subject GRE practice test. This ends up being the second of 2 consecutive L'Hopital's rule questions. Although I think this one, it's a little bit less obvious that you're using L'Hopital's rule than it was on question 7. So first, let's just kind of make sense of what's being asked. We have this function f, and the way it's defined is it's usually equal to the log of x over x squared minus 1. But if x is equal to 1, it's equal to a. Maybe you're more familiar with functions of that nature being written this way, this kind of piecewise notation. First off, I refuse to write log for natural log. It's ln where I come from. Our function takes on one of these two values. It takes on this value if x is equal to 1, and it takes on this value otherwise. In other words, if x is not equal to 1 and x is greater than 0, which it needs to be for the natural log to be defined. And what we're asked, a fairly common question about these piecewise functions, is what would a have to be in order to make this continuous, specifically continuous at x equals 1? Well, I guess the first thing is we need to understand what it means to be continuous at a point. I think in the typical definition of continuity at a point, they use the letter a to signify the point, but a has a different meaning in this problem, so I'll use the letter c instead. When I think about continuity at a point, I really have a picture in mind. So I've got this function, and I've got this x coordinate c, and what I need is the height of this point right here, f of c, to be the same as the height slightly to the left of this point, and I need that to be the same as the height slightly to the right of this point. This idea of slightly to the left and slightly to the right is made more concrete mathematically with the concept of limits. So really what I need is f of c to be the same as the limit as x approaches c from the left side of this function, and I need that to be the same as the limit as x approaches c from the right side of this function f of x. I draw the little people here because I kind of think about this person as sort of walking along the graph, getting arbitrarily close to an x value of c, and I'm asking myself about their kind of height on the graph. And if that person starts from the left, it's the limit as x approaches c from the negative side. If that person starts from the right, it's the limit as x approaches c from the positive side. You're probably familiar with all that. Anyways, in this problem, the value of c that I'm interested in, the point of continuity, is 1. So what I need is f of 1 to be the same as the limit as x approaches c from the negative side of f of x, which needs to be the same as the limit as x approaches c from the positive side of f of x. Instead of considering these two one-sided limits individually, I can just consider the two-sided limit, the limit as x approaches c of f of x. I'm told in the problem that f of 1 equals a, so a is the limit as x approaches c of this function f of x. And I'm asked what would a have to be in order for this function to be continuous. In other words, a has to be equal to this limit. Evaluate this limit and I'm done with the problem. Okay, so what is the limit as x approaches 1 of this function, natural log of x divided by x squared minus 1? Note that for the limit as x approaches 1, we're not concerned with the value of the function at x equals 1, so we use the rule for when x does not equal 1. Well, let's just blindly try to evaluate this limit. What if I change all the x's into 1s? The natural log of 1 is equal to 0, and 1 squared is 1, but 1 minus 1 is 0. What I'm saying is this limit is an indeterminate form. It's the 0 over 0 indeterminate form. What that means is I can use L'Hopital's rule to change this limit into a different limit, which hopefully I'll be able to evaluate. If you need more review on L'Hopital's rule or the different indeterminate forms, just look at the video for question 7, the one I just finished making. I don't need to repeat all that stuff. Anyways, L'Hopital's rule just tells you to take the derivative of the top and the derivative of the bottom. The derivative of the natural log of x is just 1 over x. The derivative of x squared minus 1 is 2x, using the power rule over here and recognizing that the derivative of this 1 is 0. I stare at this thing and I hope it's no longer an indeterminate form. It's not. You could rewrite it algebraically if you want, but you don't even need to. We can just change all the x's into 1s in this form. 1 over 1 is just 1. 2 times 1 is just 2. There's no issues with the left side or the right side. The two-sided limit is equal to 1/2. And as we saw before, in order to be continuous, the height of the function at the point 1 must be equal to that limit, must be equal to 1/2. What that means is that a here is equal to 1/2. Looks like B is the correct answer to this question.